Hello, welcome to another TeacherToken tutorial. We're going to be looking at truth tables, which is part of topic 1. The specification reference is 1.3.1 from Edexcel GCSE Computer Science. And this will be good for in preparation for any questions that come up on truth tables in the exam. So, I think it's worth knowing about what logic gates look like. So logic, because they're really at the fundamental building blocks of computers. So you only need to know really permutations of 3. There are more, but for Edexcel you just need to know 3, and or not. Conjunction, disjunction, or negation. You don't need to know about things like XOR or other things like that. And I think it's also worth knowing what they look like. So you might have 2 inputs, A and B, and again 2 inputs, A and B, and OR looks a bit like this. And then you have your output. Let's call it P. And NOT is simpler because it just inverts a value. Okay, so that's what they look like. And what are the truth tables for those? So let's say we've got A and B. What are the different permutations we could have? We can have 0, 0, 0, 1, 1, 0, or 1, 1. Those are the only types of input we can have there. And what could P be in that case? Well, in order for this to work, both A and B have to be 1. They have to be true. They have to be turned on for the output to be 1. So 1 and 1. So 1 and 1 equals 1 in this case. The rest of them, they're all going to be 0. So it doesn't matter if you've got a 1 in there, but if you have to have both of them to be 1 for the statement, for the output to be 1. For OR, only one of them, one or the other, needs to be on. So let's go here, A and B, output, same deal, 0, 0, 0, 1, 1, 0, 1, 1. In this case, the only one of these that's 0 is when they're both 0, but 0 or 1 is a 1. 1 or 0 is a 1. 1 or 1 is a 1. And here, you've only got one input there, A, and if that's a 0, P is, let me write that properly so my colour's not a bit off. P is 1, it inverts it, and then if A is 1, then the output is 0. So you've got to know and memorize those 3. Just memorize them. And or not. So let's look at an exam style question here. Complete the truth table. Okay, A and B. Well, A and B is most definitely 0. Not C is the opposite of 0, which is 1. And here we go. We know what this expression is, A and B. We know that's 0. Or not C. So 0 or 1 equates to 1. Here we go, A and B, again it's 0. They're all going to be 0. For A and B, the only ones that will be 1 are these 2. The rest of them, I can fill them in already. because they can't be anything other than 0. Not C, so it's just the opposite. So you need to remember that you invert it. So not C, and just going to put the opposite of whatever those are. 1 and 0. So now we've got both sides of this. Let's have a look. 0 or 0 outputs as 0. It's just 0, isn't it? Get this 0 or 1 is 1. It's the same as last time. 0 or 0 is 0. 0 or 1 is a 1. 0, 0 is a 0. Now 1 and a 1 is a 1. And 1 or a 0 is a 1. That's it. That's the truth table. Now, if you didn't remember what not or and was or was, there's no way you'd be able to get that right. But with a little bit of logic there, it's okay. So you work out the steps for this one before you actually get to it, which is quite handy. But you need to remember that logical operator OR just needs one of the sides to be true for the whole thing to be true. That's what you'll need to know. That is what you'd need to know. I mean, let's do a more complicated example anyway. Let's do a more complicated example with a diagram. So let's just say I go to an OR gate at the end. P, I've got 2 inputs to it. Let's say we call them C and D. And I've got an input here, A. And this one goes to a NOT gate here. That's B, and there's a junction there. Let's look at let's look at the table for this. So I've got A and B, and I can either have 0, 0, 0, 1, 1, 0, or 1, 1. And let's have a look at all the different permutations here. We could have C, D, or P. What are they all going to be? So let's look at the first one. If B is 0, that's going to go up here, and A is 0, then C is going to be 0 and 0, which is 0. D is going to be, there's not B, so it's going to be the opposite of that, because if that was 0, it gets inverted and it goes to 1. Okay, so and then P, let's have a look. This is an OR, essentially. This is an OR. We write it in the middle, actually. OR and NOT. So C OR D, and D is 1, so the output is 1. So let's do 0 and 1 for A and B. Now the AND is going to be 0. In fact, the AND is the only way to get a 1 is if both of them are 1. So I'm going to fill those out already. And D is just the invert of B, so that's 0, 1, and 0. And then P is C or D. So 0 or 0 is 0, 1 or 0 or 1 is a 1, and a 1 or a 0 is a 1. And that would be a demonstration of how you could combine logic gates and create a truth table based on a logic diagram. You don't really need to worry too much in Edexcel about the diagrams. I'm pretty sure that they've removed it from the specification. But they will likely ask you about truth tables and being able to fill them out. with logical statements. So I'm pretty sure that the 2020 ICP2 spec doesn't have logic circuits anymore, but expect questions like this one that we did. But I think it's useful for general knowledge to have an idea of what these look like, because they're such fundamental building blocks of computers. Okay, hopefully that helped, gave you a little primer, and it's worth just memorizing those 3 truth tables before the exam.